cup of coffee is taken out of a microwave and placed in a room. The temperature in degrees Fahrenheit, temperature T in degrees Fahrenheit of the coffee after T minutes is modeled by this function. What was the temperature of the coffee when it was first taken out of the microwave? So that would be at time T equals 0. So I'm going to plug in for little t, because little t represents time. I'm going to plug in at 0. Oops. 70 plus 130 e to the negative 0.04555 times 0. Well, anything times 0 is 0, and e to the 0 is 1. So this is 70 plus 130, which is 200 degrees Fahrenheit. So that was the temperature of the coffee when it came out of the microwave at time t equals 0. What temperature does the model predict for the coffee after 20 minutes? So now I'm going to plug in for little t, representing time, 20 minutes. So this is 70 plus 130 e to the negative 0.0455 times 20. And I'll have to use my calculator for this one. $70 plus 130 e to the negative 0.04555 times 20. 122 degrees approximately. And then C, what is the limit of the temperature to which the coffee will cool? And what does this temperature signify? Well, I'll have to look at a graph to see what temperature my coffee is approaching as time gets further and further on. So let's put my function into y1, 70 plus 130 e to the negative 0.04555 x. And maybe I'll just look at my table and I'll plug in bigger and bigger values for x. So 10 minutes, 100 minutes, 1,000 minutes, 10,000 minutes after the coffee comes out of the microwave, 100,000 minutes. It looks like 70 degrees is the limiting value. 70 degrees, and that is the temperature of the room. The temperature of the coffee will eventually approach room temperature. And it can't get any colder than that.